Hello and welcome back to my channel. So continuing on from last week's video, this week's video we're going to be looking at geometric series. So last week's video we looked at arithmetic, this week we're going to be looking at geometric. So the main difference is that arithmetic sequence you have your a plus the common difference, first term a, then a plus the common difference, then a plus 2 times the common difference, then a plus 3 times the common difference, and so on, adding the common difference each time. With a geometric series, you're multiplying by a common multiple each time. So you'd have a, AR, we call it a common ratio, so that's why it's R. AR squared, AR cubed, and so on, until you get to AR to the n minus 1. n minus 1 in the same way that it was n minus 1 times d in the last one. Because our first term, r to the 1 minus 1, is just r to the 1, so our first term is still a. A common example of this is the powers of 2. So if you have a series of 1, because this is a sequence at the moment, the series would be a plus AR plus AR squared, and so on. A common example is the powers of 2. So 1 is just 2 to the 0, plus 2, which is 2 times 1, plus 4, which is 4 times 1, plus 8, plus 16, and so on. And that's a common geometric sequence. So what we're going to do now is we're going to work out the formula, or a more general formula, to work out the sum to n of a geometric series. So first of all, the sum to n is going to be equal to a plus, I'm writing out this formula now, and I realise we said we'd find this formula, but this one is quite, it's got a lot of terms, and you can't write it simply. It's not very elegant, so then we're going to go through a process to make it more elegant. So we have a plus AR plus AR squared plus all the way to AR to the n minus 1. So that's what we have there. And what we want to get rid of are all these terms in the middle, because I don't really want to have this, especially. I don't want to have a dot 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 in the middle of my formula, because that doesn't look very nice. So, and also I don't really want to have an n minus 1 in my formula. So I'm going to, just because it doesn't look neat, so I'm going to do the sum to n times r. And that's going to be AR plus AR squared plus AR cubed all the way to AR to the n, because r times AR to the n minus 1 is just AR to the n. Then what I'm going to do is I'm going to do the I'm going to do the sum to n minus, no, I'm going to do the sum to n times r minus the sum to n. So sum to n times r minus 1 will be equal to the only terms that aren't crossing are the terms that aren't in these brackets, so the AR to the n and the a. So we're going to have AR to the n minus a, which we can write as a times r to the n minus 1. Now that's the sum to n times r minus 1. So we don't really want the r minus 1, we want just the sum to n. So therefore, the sum to n is equal to a times r to the n minus 1 over r minus 1, because we've just taken this r minus 1 over to the other side. If you multiply this by minus 1 top and bottom, you can get a more useful form of this formula for r less than 1. So you'd have a times 1 minus r to the n over 1 minus r. These are equivalent expressions. It's just this is more useful. I won't write this. More useful for r less than 1. Now, there's another form of this, because if we want to do a sum to infinity, the mod, in order for it to not be infinite, if we want the sum to infinity to not be infinite in either positive or negative direction, then mod r must be less than 1. Let's deal with this case. So if mod r is less than 1, then r is less than 1. That's fairly simple. But it also means that r is a fraction. So we'll be using the a times 1 minus r to the n over 1 minus r, because it's r less than 1. So the sum to n will be equal to a times 1 minus r to the n over 1 minus r. However, I'm going to modify this and say that the sum to infinity is equal to that. Now, if r is a fraction, when it is to a power of infinity, it tends to 0. So that really will cancel out this term, and we'll just be left with a times 1 on the top. So that tends to a over 1 minus r, which is the sum to infinity. A common example of this is if you were, let's say, to watch a YouTube video, I don't know, one of mine, and it was, let's say, an hour long, because I don't make videos that long, usually. I might, but I don't, usually. And let's say you watched it one time, and the next time you watched it double speed, and the next time you watched it quadruple speed, and the next time you watched it 8 times speed, and and so on and so forth, until you got to 2 to the n minus 1. So 1 over 2 to the n minus 1. So I'll put a dot in the middle, plus. Yeah, over 2 to the n minus 1, just make sure I've got that correct. Yeah, I have got that correct. So, the common difference, the common ratio is to multiply by a half. So r is equal to 1/2. And therefore, the sum to n, or rather the sum to infinity, as this keeps on going, of this sequence is equal to a, the first term, over 1 minus a half, which is equal to 1 over a half, which is equal to 2. That's the most common. So if you were to infinitely do this, you would come out to only 2 hours of actual viewing. That's a common example of how a geometric series is used. Anyway, thank you very much for attending this video, and I look forward to seeing you all next time.